Good morning, ladies and gentle people. Welcome to my AP Physics 1 Live Kahoot multiple choice review. My name is Mr. P. Yeah, good. All right. Please get started. I want to get started as soon as I can, but I'm just going to wait a little bit. I have a few little things to say. So here we go. Let me say my few little things. Please sign up for the Kahoot. You're clearly doing that. Please realize I have an exclusive Kahoot review for my ultimate people on Thursday, May 13th at 7:30 p.m. Eastern time. So I'm basically going to do this again with 14 different questions than these. So yeah, sign up for my Ultimate Exam Slayer and my Ultimate Review packet, please. I'm getting excited. Look at all of you. All right, this is fun. All right. This is fun. Okay, here we go. I do have a few items to say before we begin the Kahoot, and I will pause for a little bit while that's just watching the numbers go up. This is hilarious. Okay, so first off, realize on section 1 there are 40 multiple choice questions in 80 minutes. There are roughly 2 minutes per multiple choice question. So that means on this Kahoot today, you will have 2 minutes for each question. So I am going to wait the full 2 minutes because that's how long you're going to get on the multiple choice questions on the exam. And I think it's important that you realize how long that is. And the best way to do that is to actually go through and take the 2 minutes for each question. So just so you know, this multiple choice quiz uses the AP Exam Simulator, which is in my Ultimate Exam Slayer, and the AP Exam Simulator is not created or endorsed by the College Board or Blue Book. And I will post this multiple choice quiz with my solutions in my Ultimate Exam Slayer and Ultimate Review packet after we are done. Oh, I'll wait a few more minutes to get started. Actually, I do need to transition, don't I? I know you need to get your calculator and your formula sheet. I will wait a few moments. Yes, the calculator. Here, we'll do this. This is fun. Is the calculator allowed for every question? Yes, the calculator is allowed for every question. Please remember to bring your calculator and answer every multiple choice question because, hello, you don't lose any points for getting any multiple choice question wrong. So yes, make sure you answer every multiple choice question. I thank you. Here, let me do this. Blah, 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 blah. So many Chinese international students would like to offer help for translation. I thank you so much for your offer of help. Unfortunately, YouTube / Google / Alphabet has made it very difficult to get help like that. So what I'm doing is I'm actually going through and using their auto translate. So I am going through and doing that to add Chinese, but I went through and I did Chinese traditional, and I've learned that I need to do Chinese simplified. So I'm going to, in the next month or two, I'm going to go back and add Chinese simplified to all of my videos as well. I do have another question here. Is there Desmos? So I'm not going to have Desmos here. I can't do that for you. But yes, in Blue Book, there will be a version of Desmos that you can do. All right. No. Oh, God, do we get a physical equation sheet? So no, unfortunately, you do not get a physical equation sheet. This is one of the things AP physics teachers have been complaining about. You get the little pop-up in Blue Book. You should just be familiar with that. So please, please do that. Okay, here I go. So I need to transition. Give me a moment. How am I going to do this? I need to go here. Boom. Yeah, so give me just a moment. I need to transition from one to the other. Bum, bum, bum. All right, so bring this over here, and this is going to go there. And this is going to go here. All right. Oh, we're so close. We still have people being added, so I will wait a few more moments. Okay, so here, I guess I'll answer some more questions while I'm waiting. So here, So are you able to post a free response breakdown for Physics 1? So in my Ultimate Exam Slayer and the Ultimate Review Packet, actually this year, I have my solutions to every free response question, AP Physics 1 free response question that is applicable to the current curriculum. So, I have all of them. Please realize it's in my Ultimate Exam Slayer. So how many people do we have in the Kahoot? I don't know, 333 it looks like. Check this out. Oh, yes, this is correct. So the equation sheet is electronic in Bluebook during the exam. So you're not going to get a physical sheet of paper, but you will have an electronic version during the exam. All right. I'm going to wait one more minute. You all have one more minute. Oh. Oh God. Okay, so again, what are the free response question changes from last year to this year like? In my Ultimate Exam Slayer, I go through and I talk about every single version of the multiple choice questions and what to expect from them. Please, please get it. I go through and answer that question. Okay, bruh, just start. Interesting. Why is start not shortened? I don't know. All right, fine. Here we go. Sure. Would we receive scrap paper for working on? Yes, you should receive scrap paper. You can just ask for scrap paper. You will get them. Okay, so here we'll do this one. You do get a scratch paper. So for the free response questions with diagrams, will we have to redraw them on the paper? So you will, on the little booklet, you'll have a little dot, and you need to draw the free body diagram on the little dot. I'm gonna put this one on here. I don't know why you don't get an equation sheet. Not my choice. Okay. All right, here we go. I think I'm gonna get started. So people can join when they want to. So I'm gonna click on the start button over here, and here we go. A Kahoot by me, blah blah blah. Okay. Right. So here we go. Question 1 looks like this. Yes, the Kahoot is still open. You can still join. The Kahoot code is right at the bottom of the page in the lower right-hand corner, or bottom of the screen, right down there. Thank you, Kira. All right, here we go. All right, so here is what we're going to do. So here we go. So in question 1, the slope of a position of function as a function of time curve is velocity. So my face is not covering up part of the question. Sorry, it's not. In this problem, we are solving for impulse. So impulse is equal to 3 different things. It's equal to the average force times change in time. It's equal to the change in momentum. And it's equal to the area under the force versus time curve. So this is a question for all of you. Which impulse equation do we use for this problem? Please answer the question. Which impulse equation do we use? So I'm going to highlight. So I got a couple people that said mass times velocity. Please realize mass times velocity is not correct. It is change in momentum. And change in momentum is final momentum minus initial momentum. So it is mass times final velocity minus mass times velocity initial. It is this delta symbol that you all have a tendency to just ignore and forget about it. But please remember this delta is so important. Please. So in this question, we know the mass of the object that's given in the problem. So we're going to draw 2 best fit lines through the data and to find the initial and final velocities. So for the initial best fit line, we are going to, you could see that first initial point is at 0,2 meters. The final point is at 1.25 seconds and 4.5 meters. And so for this first one, we get 2 meters per second for that initial velocity. For the final best fit line, the 2 points are 1.25 seconds and 4.5 meters, and then 2 seconds and 1.5 meters. And again, you can go through and you could plug in those numbers, and it's you get -4 meters per second for the final velocity. So from there, you can see that the impulse, which is equal to the change in momentum, is equal to the mass times velocity final minus mass times velocity initial. You can plug in all the numbers. You get -0.9 Newton seconds. Now, realize that because the question asks for the magnitude, we can ignore that negative. So the correct answer is C. Now, I will point out, I talked about if you actually use a positive slope for the final velocity, you get the incorrect answer of 0.3 Newton seconds. So please realize you're going to get, if they know common mistakes that you're going to make, and they are going to put some of those answers in. So please be very careful. All right. Let's go through and do, so that gives you incorrect answer choice. So now we're going to move on to question 2. Actually, here, we'll do this. Let's see who's, we got Mountain Sable is on top. All right, here we go. So the next question, boom and boom. Next question. We are on the wrong question. Dang it. That is sad. Thanks. Okay. Sorry. Is there a way to go back in Kahoot? I don't know. I apologize. It happens. Yeah, no, I agree. All right, yeah. So it's not surprising, but there we go. Okay, so I apologize. That was my fault, but there's nothing I can do about it. So there you go. So here we go. In question 2, we have a ball is thrown with initial speed, and this question. So it's important to look at the questions and notice the structure of each of the answer choices. So these are an answer and a reason. So notice like the minimum the speed of the projectile is either 0 or the speed divided by 2, right? So there's only 2 answers to the question, but then there are 2 different reasons for it. And each of the reasons has to do with the acceleration of the object in either the X or the Y direction. So a projectile is moving at its minimum speed at the top of its path. So class, what do we know about the speed of a projectile at the top of its path? So it is important to recognize that the speed of a projectile at the top of its path is not 0. The speed of a projectile in the y direction at the top of its path is 0. It's a very important distinction. So what happens here is we know the correct answer is not 0 because it is moving in the x direction. So it has a speed in the x direction. So you don't have to figure out what it is. We already know that the speed is going to be v over 2 because that's our only option other than 0. So the question now is the acceleration of a projectile is 0 in the x direction. So the correct answer is D. Now, we didn't have to actually algebraically solve for the value of the minimum speed to solve this multiple choice question. However, we are going to do so anyway. So we have this velocity v given at this angle, and we can solve for the velocity in the x direction, speed in the x direction, or the speed in the y direction. So cosine theta equals adjacent over hypotenuse, or the speed in the x direction divided by the speed. Cosine of 60 degrees is 1/2. So the correct answer is that v over 2. All right, question 3. Again. Good luck. All right, here we go. Hopefully we'll move on to next question 3. Yes, I'm going to leave this up so this, or my plan is to leave this up so that you can watch it afterwards if you need to go to bed because it's 2 a.m. I totally understand. All right, here we go. The correct answer is B. Let's talk about why. So, question 3. So, which of the following free body diagrams best fits this? So, what we need to do is we are going to categorize the answer choices here, actually. So, let's take a moment to do that. You could see that we have either one or two upward forces, right? So it's either one or two because there's one force down in all of them, and the total upward force is either equal in magnitude to the downward force or equal to 2 times the downward force, right? So those are our basic answer choices. So we want to isolate the object we're going to draw the free body diagram of. So let's do that real quick. You could see when we look at here we go. So when we isolate the object, just that pulley, there is one downward force and there are two upward forces because there are 3 of these strings. So there's one down here and 2 up. So the correct answer is either A or B. And if the net force equals 0, A is correct. And if the net force equals a positive number, B is correct. So is the net force 0 or positive? So I've got people saying 0 and I've got people saying positive. So it says in the problem that the whole system is accelerating upward. So it has a positive net force. So the correct answer is that the correct answer choice is B. Again, it says in the question that the box is accelerating upward. You have to be careful to read on these exams. It is very important. I cannot stress it enough. All right, let's move on to question 4. Question 4. So it says, just the box is accelerating upward right there. All right, here we go. Let's see. Here we go. Boop-a-doo. All right, Jolly Griffin. Congratulations. Next. Question 4. The live stream is until it's done. We're going to do 14 questions. My best guess is it's going to take an hour and a half, but I don't really know. And I'm sorry, I'm not going to do shout outs. It's just not going to do it. All right, here we go. Looks like the correct answer is choice B. Let's figure out why. So in this question, so question 4. So we have already drawn the free body diagram. We already have the free body diagram. Now we just need to sum the forces, right? It's a question for you. We've already drawn the free body diagram. So we just need to sum the forces. So why is it wrong? That's the question I have for you. Right. So it's important to recognize that they've switched the focus of the question from the pulley to the box. So a lot of people are just going to look at this and be like, well, I already drew the free body diagram. We could sum the forces. So you have to be really careful again to read. Perfect. So no, the free body diagram we just do is not for the box. So the free body diagram for the box. The force of tension is upward and the force of gravity is downward. That's it. There's a force of tension upward and a force of gravity downward acting on the box. So we sum the forces in the y direction on the box. We get force of tension minus force of gravity. And we know then that the force of tension equals the force of gravity plus mass times the acceleration in the y direction. We already established last time that the acceleration of the box is upward and positive. Therefore, we get that the correct answer choice is B. The force of tension is greater than the force of gravity. Now, it is interesting to point out that answer choice A is incorrect because it could be true. However, we do not know it to be true. This is an important thing to recognize about the AP exam. Sometimes they're going to have questions like this. It says, which of the following do we know to be true? We know the force of tension is greater than the force of gravity, which means it could be the force of tension is greater than 2 times the force of gravity, but we do not know that to be true because we do not know the acceleration. So again, please be careful. All right, question 5. Here we go. Actually, let's check in. Let's see how everybody's doing. Where'd my cursor go? There we go. Question 5. Glad Pelican, welcome. All right, let's do the next question. Hopefully move on to question 5. There we go. All right, there you go. Question 5. The correct answer choice is D. Before we move on, I have somebody who keeps asking for me to do an AP Physics C Mechanics Kahoot review like this. I'm sorry. I just don't have the time this year to do something like that. I just don't have the time. Also, I've had a couple of people giving me $2, which I much appreciate. I also much appreciate that it's $2. I get it. I understand the humor. Thank you. I'm entertained. All right, so here we go. D is the correct answer choice. Let's figure out why. So in this question, question 5. All right, so here we go. Question 5. So this is what we know about all of these answer choices in question 5. It's always the brick earth system. So one of the things to be careful in these questions is that sometimes they change up the system. So it's the brick earth system, although question C doesn't have to do with a system. It's just the brick itself. So I guess that got to be careful of that. So the question has to do with the total mechanical energy, kinetic energy, and work. So that's just kind of some general stuff. So when you have a lot of different answer choices like this, for me personally, I think it's a good idea to just kind of look at the question and identify what you know before you start looking at all the answers, or specifically looking at all the answers, because it can kind of be way too much. So real quick, the force of gravity on the brick is down. The force the person applies on the brick is up. The displacement of the brick is down. So we know the person does negative work on the brick because that force applied is up and the displacement is down. And the angle between those two directions is 180 degrees. Cosine of 180 degrees is negative. So the force applied does negative work on the what is it, a brick? The brick. So the brick moves at a constant velocity. So these are all things we know about the event. So let's go through and look at the answer choices. So choice A, the person does negative work on the brick. So choice A is incorrect, right? So again, it's just going back to the things that we identified. Choice B, the gravitational potential energy of the brick Earth system decreases as the brick goes down. So answer choice B is incorrect. Choice C, the mass and speed of the brick are constant, so the kinetic energy of the brick remains constant. So answer choice C is incorrect. Choice D, the total mechanical energy equals the kinetic energy plus the gravitational potential energy. Because the kinetic energy is constant and the gravitational potential energy decreases, that means that the total mechanical energy decreases and the person does negative work on the brick. So the answer choice D is correct. So I just got a question. We'll do this real quick. Can I do that? No. Why is the force applied up? So person slowly is lowering a brick straight down at a constant velocity. So in order for that to happen, that force needs to be up. If you look, as I lower my phone down, that force that I'm applying is up. In the absence of my hand, in the absence of that force applied, the brick is actually going to accelerate downward. So what the force applied up is doing is it's preventing the brick from accelerating down. All right. All right. So here we go. Let's go back here. Where is it? No. All right. So we move on to, actually, let's see how everybody's doing. Glad Pelican, congratulations. Next, let's move on to the next question, question 6. All right, the correct answer choice is B. Let's take a look at why. So in this question, next. All right. Let's, it's hard to get my face out of there. Let's try, well, whatever. Let's try this. Whatever. It'll work out. All right. So question 6. So there's no real structure to these answer choices. And maybe just try. So there's no real structure to the answer choices. So each answer choice is independent. So choice A, if the projectile is moving to the right, there is a drag force to the left. This will slow the projectile down. However, it does not cause the projectile to accelerate in the y direction. So answer choice A is incorrect. Answer choice B, does the force of gravity on the projectile cause it to accelerate in the y direction? Class, that is a question for you. Does the force of gravity on the projectile cause it to accelerate in the y direction? Yes, the force of gravity causes it to accelerate in the y direction. So this is what causes all projectiles to follow a parabolic path. So answer choice B is correct. Perfect. Just, answer choice C is just a garbage mashup of physics words. So choice C is incorrect. Just all the words just together don't make any sense. So answer choice D is incorrect. If you just look at answer choice B, you'll see that answer choice D is incorrect. All right. Beautiful. Let's move on to the next question. All right. Soaring otter has soared to the top, if you will. Next question. Boop. All right. And next. All right, here we go. Correct answer choice is C. Let's figure out why. So here we go. Next. All right. So question 7. This is a straightforward rolling without slipping problem. The equation for the velocity of the center of mass of an object rolling without slipping is not on the AP Physics 1 equation sheet. So please be aware of that. There are some equations that just are not on the equation sheet for whatever reason. In my Ultimate Exam Slayer, I do have a video where I go through and talk about the specific equations I would suggest that you memorize for the AP Physics 1 exam because they're not on the AP equation sheet. So the equation is the velocity of the center of mass of the object equals the radius of the object times the angular velocity of the object. So we can set that equal to the equation for average velocity. So the velocity of the center of mass equals the radius of the object times the angular velocity, which equals the displacement of the center of mass of the object divided by change in time. So you can solve for the displacement of the object. It equals radius times angular velocity times change in time. So the correct answer is C. Now, it is interesting to point out that, and this happens sometimes, that answer choice C is the only answer choice with the correct units. So sometimes, no, Hulk, it is not on the equation sheet. Trust me. So answer choice C is the only one with the correct units. So sometimes this does happen. So be aware if you are struggling on a problem for whatever reason, you can look at the units of the answer choices and sometimes figure it out that way. Cool. Here we go. Let's see how everybody's doing. Ooh, Soaring Otter still on top. Next question. Boom. Here we go. Question 9 or question 8. Yep. All right, the correct answer choice is B. Real quick, let's address what people are, just because people are asking this question. So here we go. This is fun. So the equation that I talked about, I'm looking at it right now. No. Is this on the sheet? No. So there is a similar equation that says V equals R times omega. This is for the tangential velocity equals the radius of the object times the angular velocity of the object. Now, this is a different equation. Yes, there is an equation for the position of the center of mass equals the radius times theta. That is on the equation sheet. So you can look at all those and see that there are the 3 equations for velocity of the center of mass, acceleration of the center of mass, and the displacement of the center of mass. But they're kind of mashed together. So you just have to be careful and realize that they're sort of on there, but they're really not all on there. It's a very strange thing. All right, let's come back to this question. All right, so here we go. Question 8. All right, so question 8. So what forces are acting on the block at position 4 and what are their directions? So that's a question for you. What forces are acting on the block at position 4 and what are their directions? So we have two forces. The forces are the force normal, which is inward or to the right at position 4, and we have the force of gravity, which is downward. So that means, and there is no force of friction in the problem. So therefore, the force normal is inward, the force of gravity straight down. So that net force is down and to the right. So the correct answer is B. Perfect. Question 9. Oh, actually, here we go. Sorry. Soaring otter. Congratulations, soaring otter. All right, let's go to the next question. Question 9. All right, here we go. The correct answer is C. Let's figure out why again. All right, here we go. Here we go. So the graph has a constant slope. What is the slope of an angular velocity as a function of time graph? Right. It's angular acceleration, just like the slope of velocity versus time graph is linear acceleration. The slope of an angular velocity as a function of time graph is angular acceleration. So we could see here that the angular acceleration is constant. So we now know the angular acceleration of this object is constant. Choice A has to do with net torque. So the net torque we know is equal to rotational inertia times angular acceleration. We know the angular acceleration is constant, so we know the net torque is constant. So answer choice A is incorrect. Answer choice B has to do with angular momentum. We know angular momentum of a uniform solid object is the rotational inertia times the angular velocity of the object. So the angular velocity is changing, so angular momentum is changing. Therefore, answer choice B is incorrect. Answer choice C has to do with rotational kinetic energy. Rotational kinetic energy equals 1/2 the rotational inertia times the angular velocity squared, angular speed squared. So rotational inertia is constant and angular velocity is increasing. So rotational kinetic energy is increasing. Answer choice C is correct. Answer choice D, a uniform solid disk has a constant rotational inertia. So answer choice D is incorrect. Great. Let's move on to question 10. But of course, let's see how this is going. The scoreboard, Soaring Otter. Well done, Soaring Otter. Next question. Let's move on. All right, so we need to do this. Did I do it again? Oh, I did it again. You got to be kidding me. Ah, I did it again. All right, question 10. Good luck. You have 60 seconds. Oh, that's sad. Sorry, I can't do anything about it. I agree, bro. Nah. Thank you, Boba Smith. All right. So the correct answer is D. I apologize again. It is important. I'm going to give you another 60 seconds because I think some of you ignored this question. So I want you to read through the question and think about this. Please. It's an important question. All right, here we go. I'm going to talk about this one now. So here we go. Question 10. So the graph shows the force of the spring. Here we go. This has to do with Hooke's law. Whenever you see a spring force as a function of spring length, you should think about Hooke's law. Force of the spring equals the negative of the spring constant times the displacement from equilibrium position. You know the equation for the slope-intercept form of a line equals y equals the slope times x plus b, the y-intercept. So the slope of the line is the negative of the spring constant. The best fit line for these data passes through 0.2 meters and 60 newtons and 0.7 meters and 10 newtons. So we can go through and we can figure out the slope. The slope is the negative of the spring constant, so we end up with 100 Newton meters. The forces on a mass at rest are on a vertical string, so we have the upward spring force and we have the downward force of gravity. So some of the forces in the y direction, we know the acceleration in the y direction because it's at rest, so it's 0. So we end up with the force of the spring equals the force of gravity, or the spring constant times displacement from equilibrium position equals mass times the acceleration due to gravity. So we could solve for the displacement from equilibrium position, 0.2 meters. So class, is 0.2 meters the correct answer for this question? No. But you know that some of you, when you solve problems like this, you're going to get to a number. That number matches one of the answer choices, and you are going to just pick it. So please just slow down and think, please. So 0.2 meters is the distance from equilibrium position, not the new spring length. So in order to get the new spring length, we need to take the natural length of the spring and we need to add the displacement from equilibrium position to the natural length of the spring. So we're going to take the natural length of the spring and add 0.2 meters to it. So the question is, where is the natural length of the spring? It's not actually given in the problem, but you can infer it from the graph. So where do we find the natural length of the spring? The natural length of the spring is the x-intercept of the best fit line, or 0.88 meters. We know this because the natural length of the spring is the length of the spring with no force acting on it. So if you look here, this best fit line will intersect right here, which would be roughly 0.8 meters. So that is the natural length of the spring. So the new length of the spring is 0.8 meters plus 0.2 meters, or 1 meter. The correct answer is D. Question 11. I know you're excited to see question 11. Here we go. Question 11. I know. Many of you already have it. That's okay. Here we go. Answer choice C is the correct answer choice. Let's look at why that is. Looking at the question. Here we go. So question 11. What is the slope of an angular position as a function of time graph? Correct. Angular velocity. Again, just like the slope of a position versus time graph is velocity, the slope of an angular position as a function of time graph is angular velocity. Great. So there are two constant angular velocities when you look at this graph. We have a constant angular velocity here, a constant angular velocity here, and a transition right here in the middle of the graph. So something happens in the middle to increase the angular velocity of the skater. So choice A, there's nothing in the problem statement which could cause a net external torque. Therefore, answer choice A is incorrect. The second half of the statement is correct. So realize like the whole statement needs to be correct for it to be a correct answer. Choice B, the skater brings in their arms. This decreases the rotational inertia. However, because there is zero net external torque, the angular momentum of the skater remains constant. So answer choice B is also incorrect. Choice C, The skater reduces their rotational inertia. Yes. Causing their angular velocity to increase. Yes. While conserving angular momentum. Yes. So answer choice C is correct. Answer choice D, rotational kinetic energy is 1/2 rotational inertia times angular speed squared. Therefore, their rotational inertia decreases and their angular velocity increases. So their skater's rotational kinetic energy does not remain constant. So answer choice D is incorrect. So question 12. Here we go. Let's see how people did. Soaring otter, soaring away. Question 12. Hopefully we'll move on to question 12. Here we go. That'll have to do. All right. The correct answer choice is B. Let's take a look at why that is. So, first off, realize this is the fourth question in a row with graphs in it. So, yes, you should expect to see a lot of graphs on the AP exam. Just realize it. You're going to see a lot. So, the equation for gauge pressure is that the gauge pressure equals density times the acceleration of gravity times h. Now, what is h in this equation? Right. So we need to be really careful when we talk about h in this equation. So h is the vertical depth of the water from the top of the water to the location where the gauge pressure is measured. So in this problem, little h is equal to capital H in the problem minus 2, because that is the vertical depth of the water from the top of the water to the location where the gauge pressure is measured. Now, that means we need to substitute capital H minus 2 in for little h into this equation, and we get that the gauge pressure equals the density of the liquid times the gravitational field strength times capital H minus 2 times the density fluid density times gravitational field strength. So now, realize this is y equals slope times x plus the y-intercept. Y is the gauge pressure. The y-intercept is -2 times density times gravitational field strength, and the slope is just a constant number. So this is a positive slope with a negative y-intercept. So the correct answer is B. Great. So realize there are two numbers given in this problem, and they're not used in this problem at all. So realize there's going to be information sometimes in the problems that you are not going to be used. All right, here we go. Question 13. Let's go. Let's see if Soaring Otter is still Soaring Otter doing well. Although you missed that one, didn't you, Soaring Otter, I think. All right, here we go. Next question. Hopefully we will see. The problem is sometimes I click and it doesn't work sometimes. Okay, so question 13 is where we're going next. All right, the correct answer is C. All right, here we go. Moving on to the next one. Let's zoom in a little bit. Okay. Question 13. The period of a simple pendulum is 2 pi times the square root of the length of the pendulum divided by gravitational field strength. The period of the first pendulum is just 2 pi times the square root of L over G, because the length of the first pendulum is L. The period of the second pendulum is 2 pi times the square root of 1/4 of L, because that is the length of the second pendulum. The square root of 1/4 is 1/2. So you end up with the period, the second period is equal to 1/2 times the first period. So when you're looking for the ratio of the two periods, you will get the number 2. The correct answer is C. Please realize you are pretty much guaranteed to see one of these find a ratio problems on the AP exam. They seem to come up often on the practice exam. So please be aware of that. All right, question 14, our last question. Let's see how we're doing here. All right, Soaring Otter, awesome puffin. Next, last question. Let's do this a little bit. All right. The correct answer was A. Here we go. Question 14. So we are drawing a free body diagram for U, and the question says 2 blocks. You've already read the question. So my question for you is, what piece of information is missing from the question? This is a very important thing to recognize about this question. Something is missing. No, it says that there is friction between the surfaces. It says it's not negligible. So the direction of the motion, how the blocks are moving. So it says the blocks are moving, but what it does not say is it does not say which direction the 2 blocks are moving. So we have a couple of options. The 2 possibilities are block V could be moving up the incline with block U moving down the incline, or block U could be moving up the incline and block V could be moving down the incline. Now, I've had a couple of people say stuff about friction. It says friction is not negligible in the problem, so you know there is friction between all of the surfaces. So regardless of which direction the blocks are moving, block U will have the following forces acting on it. It will have the force of gravity straight down. It will have the force of tension from the string up the incline. It will have the force normal from the incline up and perpendicular to the incline, and will have force normal from block V down and perpendicular to the incline. So there are at least these forces, one straight down, one up the incline, one up and perpendicular to the incline, and one down and perpendicular to the incline. So we know those forces are in the free body diagram. But the question now is, so the correct answer is either A or B. So the question is, how many forces are parallel to the incline and what direction are they in? So here we go. If block V is moving up the incline and block U is moving down the incline, block U will also have the following forces acting on it. The force of kinetic friction from the incline on block U, which opposes the sliding motion of the block U, which is then up the incline. The force of kinetic friction from block V on block U, which opposes the sliding motion of block U, which is also up the incline. And if block U is moving up the incline and block V is moving down the incline, block U will also have the following forces acting on it. So the force of kinetic friction on block U, which opposes the sliding motion of block U, which is down the incline, and the force of kinetic friction from block V on block U, which opposes sliding motion of block U, which is also down the incline. In other words, there are, for the forces parallel to the incline, there are either 3 forces up the incline or 1 force up the incline and 2 forces down the incline. Therefore, the correct answer is answer choice A. So block V, we know block V is moving up the incline and block U is moving down the incline. Just to complete the picture here, realize we've got the force normal from the incline. These are all the forces acting on block U. The force normal from the incline, which is up and perpendicular to the incline. We've got the force gravity straight down acting on U. We've got the force normal from block V pushing down on U. So that is in this direction. We've got the force of tension, which is caused by this string. We've got the force of kinetic friction caused by block V, which is up the incline. And we've got the force of kinetic friction from the incline, which is also up the incline. Real quick, we'll come back here. We'll check in to see how this worked out, how the podium worked out. We have blue, whatever, and awesome Puffin in 2 and soaring. Yeah, soaring eagle, was it? Soaring otter, excuse me. Soaring otter, congratulations. You got 10 out of 14 correct. That's great. All right, so real quick, we'll just finish this up. We are done. Thank you so much for being here with me today. My plan is for this video to remain live on YouTube so that y'all can look over it if you need to and other people can look at it. So this multiple choice quiz and my solutions to it will be posted in my Ultimate Review Packet and Ultimate Exam Slayer. I'll probably do that tomorrow morning. So if you want to just look through the quiz on your own, you could do that if you have access to my Ultimate Review Packet and Ultimate Exam Slayer. For all the people who are in my Ultimate Review Packet and Ultimate Exam Slayer, realize I will be doing another multiple choice review for AP Physics 1 on Tuesday, May 13th at 7:30 p.m. Eastern time. Please make sure to make use of my 30-minute exam cram video. I made that special this year for y'all. The intent is that you can use it right that night before the exam. Please make use of it. And lastly, of course, well, not quite, best of luck on Friday, May 13th. And lastly, thank you very much for learning with me today. I enjoy learning with you.
Flip